Machine learning is one of the most exciting parts of AI. It powers things we encounter every day, from YouTube recommendations and facial recognition and photos to weather predictions. But how does it actually work? Today, let's break it down. Starting off with, what is machine learning? Machine learning is a way for a computer to learn from data. Unlike traditional programming, where humans provide specific instructions for every single task, machine learning allows the computer to figure out patterns on its own by analyzing data. It's like when you're a young child and your parents tell you, don't touch the stove because it's hot. And then you touch the stove and realize, yeah, that's hot, and burn yourself. You learn that, okay, anytime something is hot, I shouldn't touch it because I'm gonna burn myself. That's similar to how the machines learn, where you train it to say, okay, X plus Y equals Z, and now knows any type of connections like X and Y, it should equal something similar to Z, which goes back to touching the stove and getting burnt. Anytime you touch something hot, you're gonna get burnt. And you learn from there. Now let's talk about some actual examples of machine learning. Let's say you want a computer to recognize whether a photo is of a cat or a dog. With machine learning, you provide the computer with a set of labeled images, some labeled cat and others labeled dog. The computer studies these examples and learns the patterns that distinguish cats from dogs, like their ear shapes or fur patterns. So for this part, think of data plus labels, the cat or a dog, equal learning. So we feed it this data of cats and dogs, and because of the labels of this is a cat or this is a dog, the machine learns, okay, this type of face structure or body structure is a cat or is a dog. Now, let's dive deeper into the key concepts of machine learning. We were just talking about this. Let's take a step further. Training data. Training data is the foundation of machine learning. Without any training data, our computer can't make decisions. But the more training data that you provide for it, the better results it can provide in future decisions. Going back to our cat and dog example, if I give it no pictures of a cat or dog and ask it, is this a cat or dog? It's guessing 50-50. But if I give it 10 cats and 10 dogs and then say, is this a cat or dog? It has data and it's been trained on previous examples. So it can say, well, how big is the body? If it's small, then it might be a cat. But if it's large, then it might be a dog. And then from there, it improves and learns. And now, when asked that same question, it can make a better decision. And because it learns from the training data, it's important that you label the data correctly. If you mislabel a cat that's really a dog, the computer is going to get messed up. And it's going to be even harder to differentiate in the future. So making sure when you're creating this training or test data that it's accurate and labeled correctly. Next, we have the algorithms, which, as I mentioned previously in other videos, is the recipe for our computer. It's going to say different ways to solve different problems. Some algorithms or recipes are good for this instance or this situation, and other ones for this situation over here. For example, some algorithms excel at recognizing objects and images, while others are better at predicting numbers such as stock prices. Next, we have our training and testing. Once we pick our set of test data as well as our algorithm, we're then going to train a computer on this test data using our algorithm. Here, it analyzes the training data to learn patterns. Once it learns the patterns, that's when testing comes in. Testing involves giving the machine new, unseen examples. This would be like new photos of cats and dogs that it hasn't seen in the past. And then we're going to see if it can correctly identify if it's a cat or a dog. If it does, then the training worked. If it didn't, we're going to correct it, retrain it on the new test data, and test it again with more test data that it hasn't seen yet, and continuously integrate to improve our machine learning. And last but not least, we have model accuracy. The accuracy tracks how correct it is with predictions. For example, if the machine identifies 9 out of the 10 animals correctly, then it has a 90% accuracy rate. But it's important that you add new items to test it against, because training models can memorize old data, in which case it'll always have a high accuracy rate because it's seeing the same things over and over. And once it gets it right once, there's a good chance it'll get it right every time after that, which is why you introduce new data to make sure that when that's introduced, it can still be accurate. As far as machine learning in the landscape of AI, think of AI as one big umbrella, and machine learning is just one part. It helps computers learn and powers technologies such as facial recognition, self-driving cars, and language translation tools. So why do we even need machine learning? As a coder and developer, having machine learning eliminates me having a code for a million different criteria. I can just train a machine on some test data, and then from there, it'll go through other variables and learn from there for me, instead of me coding every single situation, occurrence, type of variable. No, I'll be more efficient, let the machine do a lot of the work. So here's a quick recap of how machine learning works. We start with our training data, which provides examples for the machine to learn from. We then have our algorithms, which help the machine find patterns in the data. And we wrap it up with training and testing to ensure the model can make accurate predictions.